this semester. Make sure we're all in the right room. Calculus 2. Excellent. What name sounds familiar on this roster? I think I had you over the summer. That was you?
Yeah.
Oh, good. I get to torture you again, except this time it's not 5 weeks. 10 weeks if you took both my courses.
Yeah.
And it's in person now.
Yeah, it was online before.
Which is even better. Which means you're screwed, because I know you know everything I'm expecting. Because you took my Calc 1 course, right?
I took Calc 1, yes.
Obviously, this is a math course. Course number is 152, section 030. 4 credits. Full term, so we do meet for 15 weeks plus finals. Official start date was yesterday. The lecture end date is May 6th. Finals start the 7th and run through the 13th. Our exact exam date will be announced later in the semester. I'm thinking probably around spring break. Obviously, Calc 1 is a prereq with a minimum grade of C. As of right now, it'll be in this room, 18-10. I'm not a fan of this room, so I may try to change it. Unless otherwise specified, we will meet every Monday, Wednesday, 6 to 7:50. What I tend to do is, instead of giving a 10-minute break, I let out 10 minutes early. We're only required to meet for, what's it, an hour and 40 minutes a day? 1 credit hour is 50 minutes. My name is James Alker. I have the standard MCCC email address. The best way to reach me is through Microsoft Teams. I'll show you that a little bit later. It's kind of like a text message. I will get an order on my phone, and as long as it's not an unreasonable hour, and it's something I can answer on my phone, I can answer immediately. Whenever you contact me, however you contact me, please be sure to include the course. I do attempt to respond to all messages, emails within 2 business days, Monday through Thursday, typically 9 through 4. If you don't hear from me during this period, just resend the message. Probably got lost or I forgot. If you do decide to email, please only do so through your student account. Other accounts may be blocked. If you want to see me, by appointment only, using that web link. And so we'll bring you to this page. I'll give you a list of days and times. I do require 24-hour notice, which is why tomorrow's grayed out already. Pick the day, pick the time. Appointment time. Appointments are 30-minute blocks. Then you just fill out the information. You should get an email confirmation of the appointment. And then I will also, should I change these? These shouldn't be Teams. Those are going to be Zoom. And then once I schedule the appointment on Zoom, I'll also send you the invitation link. So the appointment blocks, Monday and Wednesday will be 9 through 3 with a 1 hour break, 11:30 to 12:30. And then Tuesday, Thursday, 9 to 4 with a 1 hour break, 12 to 1. I have a Bachelor's of Arts in Mathematics, as well as a Bachelor of Science in Physics with a minor in Astronomy. And I got my Master's of Arts in Mathematics, all through Brown University. I'm also currently researching applied mathematics PhD programs. Once my wife is done with her master's, I plan on getting a PhD. I tutored for a total of 3 years. 1 year was volunteer, 2 years paid. And I've been an instructor for a total of 8 years. This is my 9th. I teach at 3 schools, Rowan University, my own college at Burlington County, and also here. And I have taught just about every level 129 courses. So I actually enjoyed studying the applications of mathematics. I am independently studying economics, finance, accounting, and I am just brushing up on my physics. So you may see a lot of physics examples. I do have 2 kids. 3-year-old boy and 2-year-old girl, so my hands are full at home. Spent the last 2 weeks sick or dealing with them being sick, so that was fun. Free time, just standard watch YouTube videos, anime, play video games. Travel with the kids. Read through that on your own. Using OpenStax, Calculus Volume 2. And so if you click that link, it'll bring you to the textbook page, and there are several options of viewing it. You can either view it right online, which is the way that they recommend. That's the most up-to-date. You can download a PDF. Oh, apparently you can now download for Kindle. Okay, that's new. The PDF, they claim they update twice a year. I don't believe them. Or, if you're like me and you prefer to have a hard copy, you can order it on Amazon. $34 for brand new copy. Again, they claim that they update this every year. However, I've had that copy for 3 years, and I have checked other ones, and it's not been updated. So, take that for a salt. Office 365. MyOpenMath. Get into all that a little later. You're going to need a graphing calculator. My personal recommendation, and the one that I use, is the TI Inspire CX2 CAS. If I do any kind of calculator emulation, that's the software I use. We're also going to be using Wolfram Cloud. can sign up for a free account. That's going to be perfectly fine for what we're going to be doing. I think the only difference between the free account and a paid account is how many files you can save. I think that's the only difference. I think this only allows one for the free. And as the semester goes on, I will be showing this off as well. So Wolfram is the language for Mathematica. There will be coding, just basic coding. But we will be writing some code. And this also serves as CAS, so you can also do graphs and integrals when we get to that, derivatives, limits. Give me a microphone. You set an appointment with me. Obviously, otherwise I'm not going to hear you. And I'm trying to keep the purpose of the appointment. And again, for appointments, is recommended. Outcomes, yeah, read those at your leisure. So what are we going to be covering? We are going to pick up right where Calc 1 left off. One of the last things you should have studied in Calc 1 was change of variable, U substitution, right? That is just one of many techniques of integration. We will study the rest of them. Integration by parts. Everyone's favorite. Trig sub, which is another change of variable. Method of partial fractions. So those are the antiderivative techniques. Integration by parts you can think of as the equivalent of product rule. Method of partial fractions, kind of the equivalent of quotient rule. That's for rational functions. Trig sub allows you to do integrals of functions that involve radicals. Now, as we're going to see, integration is a lot harder than differentiation. Every single function has a derivative. Well, I should say has a derivative function. Maybe 5% of functions have an antiderivative. A lot of functions do not have an antiderivative. For example, e to the minus x squared does not have an antiderivative. However, we still want to integrate the function. This is where numerical techniques come in. So we look at numerical techniques, and then we also study improper integrals. Then we'll move on to looking at applications of integration. One of them probably is a review, area between two curves. You may have got to that in Calc 1. We look at how we can use integration to find volumes, to find densities, the average value of a function over a specified interval. We're going to look at integration and probability theory. So if you took an intro to stat course, a lot of that's going to look familiar, except you're actually going to see the math behind it. work, and center of mass. So in my honest opinion, the first topic we cover is the hardest of the semester. Techniques of integration. However, the third topic is also pretty challenging the first time you see it. And that's where we study infinite series. We look at sequences, then we define what an infinite series is, discuss how to determine whether a given series converges or not, and finally conclude by looking at power series. And we will conclude the semester with essentially pre-Calc 3 by looking at the geometry of the plane. Parametric equations and polar coordinates. Parametric equations essentially are just two vectors. And you study vectors again in Calc 3, so why this is in Calc 2, I have no idea. This really should just be omitted. Or we should just do all the vectors in Calc 2. But what do I know? Look at the software. So you all have access to a free Office 365 account. What you're going to do, and just log into my Mercer portal. It's going to be easier. Office 365 apps. I think this is going to take you right to the Office account. Sign in. It does. It just brings you right to Office 365. Up here, install apps. And 365 apps. And this will install them on your device. With one exception. It does not install Teams. Teams used to be easy to install. You just went to the Teams site, and when you logged in, it said, "Are you sure you want to use the website version, not the desktop version?" And yes, you can download the desktop version. They've updated Teams, but it no longer does that. So I found that link that allowed you to download Teams if you want it on your desktop. So let's take a look at Teams. So there are two ways you can access Teams right on the web version. So I believe it was Teams.Microsoft.com. Yeah, and it'll just bring you right to the web version. It's going to ask you to sign in. Sign in using your Mercer information. That's nice. I do not like the web version. I find it to be very laggy. So I would recommend just downloading the desktop version. It looks the exact same, except now on your desktop. So the page is already set up, and I just checked my roster before class started, so as long as you're on my roster, you have access. Look at that have 2 assignments already up there. That's nice. So assignments were posted up here. You should get emails whenever an assignment posts. Keyword should. If you download the app on your phone, you'll get alerts on your phone as well. And again, then you can also just message me right through your phone and your computer. And so up here, you'll see files. I'll get into that later. Class materials, this is where all the class materials are going to be posted. So I already have 3 tables up there for you. These 2 are pre-calc. This one in particular gives all the trig identities. I don't make you memorize them. Although I do recommend you do because it's quicker. And table of derivatives. You've passed Calc 1. Which means I hope you know how to take a derivative. So you can just refer to the table. I'm no longer testing if you know how to take a derivative. If you don't know how to take a derivative, you should not be in my course. Let's put it that way. You also see the schedule and the syllabus up there. Teams, you should just have the option to open. So you can either open in Teams or open it on the desktop app. Whichever, doesn't matter. But this is the syllabus, and it is going to be kept up to date. So if I see a mistake in there, I edit it. And the slides are basically everything that's on the syllabus, so I don't need to do that. I think this is going to open in the desktop app. And the schedule. Which again, this will be kept up to date, so if I have to make any changes to the schedule, it'll just go in there. And you should see a comment if it's a major change. Keep in mind this is tentative. As well as syllabus, it's just an object of my own. So I can change it at any time for any reason. And I don't necessarily have to tell you I changed it. But I do recommend you look at this every day. Just so you can say, oh look, there's an assignment to do on the 26th. I'll get into the exercises and all that. Remember, this gives you a rundown. I don't know why schools decide to start in the middle of the week and they can't just start on Monday. And what do I know? Some plug and teaches. I don't get paid hundreds of thousands of dollars to sit there and decide things I'm going about. First discussion, obviously that's the first assignment. Don't worry about the other 2 yet. They're going to be later in the semester. But it doesn't give me an option to hide. Don't worry about the class notebook. Classwork, this is actually a new feature that just came out in the middle of last semester, and I love it. It's now becoming a true learning management system. So modules, again, you're not going to be able to see anything except for module 1. Right, if you just click it, and it'll give you a rundown of what we're doing, assignments, all that, as well as links, videos, assignments, things like that. So it's all right there for you. As well as in the files page and multiple other locations. Yes, PowerPoints I will tend to put up there the morning that we meet. So keep an eye out. Assignments tab, this is again just another place where you'll see all the assignments. You click on it, and it just gives you detail. I'll have to right now, just going to give a list of people. Click it, it's going to give you a rundown of the assignment. And if it requires an upload, you'll upload it here. Most of them are not going to require an upload. They're purely here just for the grade book. Obviously grades. Don't have to worry about it because there's no grades in there, so it's going to show everyone with nothing. But then you'll see all your grades on the grade book. Keep hitting all that's fine. MyOpenMath. It's a free open source online homework system. 2 keywords, free and open source. Has its pros and has its cons. Pro is it's free. Con is it's free, which means they don't have dedicated staff. It's also open source, which means any Joe Schmo can write anything on there. I have encountered where the code for a problem is incorrect. They'll code the answer wrong or something. Generally, it's an easy fix. I just email the author, they fix it. But just email me if you have questions. What we will do come over to MyOpenMath. If you've already used it, which one of you at least has, then you're just going to log in. Enroll in the new class, and then you'll enter that information that was on the slide, which will be up again. First time user, you have to register as a new student. Username, password, and all that. I recommend you use your MCCC email address. You don't have to, but it is recommended. And it's going to ask you the same information as enrollment in class, course ID and enrollment key. And also the syllabus. Section 4.2, I believe it is in syllabus. So you see the list of courses you're taking down here. Just click it. Student view. The first batch of assignments are already up there. We'll discuss more how the assignments work. Click this, and that's going to give you some basic information before we start it. Obviously, we're going to be meeting in person, unless, again, specified otherwise. We'll give you a heads up. On February 7th, my daughter has surgery. I'm hoping, it's like last time, it's first thing in the morning, and everything goes well, so I can actually leave the hospital, because she'll still be asleep, and her mom will be there, and I can still make it into the class. Otherwise, we may be meeting while I'm actually in the hospital. So, we'll see how that goes. And possibly the following Monday as well, depending on when they release her. Meet every Monday and Wednesday, 6 to 7:50, right in this room, unless things change. Attendance. It is policy that you attend every meeting, arrive on time, and stay throughout the entire duration. I will be recording attendance. So if you QR code on the door. There will be one up there every class. When you come in, just scan the QR code with your phone. Fill out the 2 questions. I think you just ask for your name and your email address and submit it. And that's how attendance will be recorded. With the exception of today, the form will close 1 hour after the start of class. So if you arrive after that point, you'll be marked as absent. I think 1 hour is fair. Attendance is reported to the college only for financial aid purposes. I don't use it for grading. Other than maybe if you're borderline. I look and go, you attended, you made an effort. Recordings. All the meetings will be recorded. Used my webcam last semester and I didn't like the quality, so I decided to treat myself. I will post the recordings on our Teams page under that recordings folder that you saw earlier the following morning. So this recording will go up there tomorrow morning at some point. At the end of the semester, once I post final grades, I reserve the right to post the recordings on my YouTube channel. Teams, there was one thing I forgot to do on Teams. The chat. Right over here, chat. This is how I will be getting in touch with you. If I had to send a class-wide announcement like, there's complication of my daughter's surgery, we're meeting virtually. It's already happened, so I'm not to have that. One person. Right, so just get a message. You should already have a message, except for the one who registered just today. However, everyone can see this, so don't respond to it anything that you don't want anyone else to see. If you need to get in touch with me for personal reasons, you don't want anyone else to see it, you can just compose a new message. So you can actually go with just entering my email, right? And then send a message. I don't want to send a message to myself, that would be silly. There will be an assignment for just about every topic we cover. As of right now, there is nothing up there on polar coordinates because they didn't have any good questions. That may change. There's always questions being added every day. So if I find good questions on there, I may create an assignment for the polar coordinates. It's broken into 4 groups, 4 quarters. So that's why you see a batch up there right now. Q1 is going to cover the first 7 assignments, 1 through 7. They will all be due on February 21st. So you can work ahead. Or if you're silly and you want to wait until the 20th to do all 7, good luck. Well, you can do that as well. All right, the second batch will be due March 13th. Third batch is due April 17th. And the final batch will be due on the day of the final. Collectively, this will be worth 10% of your final grade. So each one is going to be 2.5%. Before quizzes, they're on the schedule. They will be take home. Use notes, textbook, official class handouts, and and any CAS of your choice. And in fact, some questions may require the use of Mathematica. Like for instance, when we do numerical integration, that's on quiz, I may require you to write code for the quiz and attach a printout of your code. Collectively, they would be worth 15% of your final grade. First exam will be take home. So, notes, textbook, class handouts, and CAS of your choice. Again, it's take home, so I may require you to write code in Mathematica. The first exam is worth 10%. Second exam is the midterm. This will be in class. You'll be allowed to use printed notes, printed class handouts, and any model calculator. So this is going to require no Mathematica coding. This will cover all the topics that we did during the first half. Right now it's scheduled for March 13th, which is the Wednesday before spring break. The midterm will be worth 20%. Third exam, similar to the first exam. We take home, answer like the same things. It'll only cover the topics covered since the midterm, and it'll also be worth 10%. Then the final. I'm required to make it comprehensive. This will be in class. So again, printed notes only, printed handouts, and a calculator. It'll cover all the topics. Scheduled for finals week. Again, I'll announce the exact date later. Final will be worth 30%. Because it's comprehensive, so it should be worth more. And then there's going to be a bunch of miscellaneous assignments. There's going to be a large variety of them. Discussions, group assignments, coding assignments. I have some reflections of them as well. These will be worth collectively 5%. And the grading scale is just the typical MCCC grading scale. A, 93 to 100. A minus, 90 to 93. B plus, 87 to 90. B, 83 to 87. B minus, 80 to 83. C plus, 77 to 80. Then you have C, D, and F. No one's going to get it about, right? College resources, including withdrawal dates, refer to section 7 in the syllabus. So some closing remarks. Calculus 2 is considered by many to be the toughest in the sequence. I disagree with that. I think Calc 3 is the toughest. That's probably because I teach it the right way. So Calc 3 is Calc 1 and Calc 2 in multiple dimensions. Mathematics is a participation sport, right? You can't just sit there and observe. You actually have to be active in it. So this includes reading the text. Yes, you actually do have to do a lot of reading in math. Reading the proofs. Ah, the dreaded 5-letter P word. supposedly many, many times until you kind of understand what's going on. Luckily, the proofs that we look at are very short. There are very long proofs out there. There's a 500-page proof. Reviewing the notes, reviewing the exercises we do in class, actually doing the exercises. The practice exercises I have listed would be a good place to start. For my open math, you do have 100 attempts on each assignment. And the reason stop more is because it doesn't give me an option for more. I would give unlimited until the due date if I could, but that's not set up to do that. Hundreds maximum, so that's what you get. 5 tries on each question. There is a 20% deduction, though, for each incorrect try. Once the due date's passed, they do remain open for practice. So you could go back after the Q1 batches due, for example, and continue to work on the problems. You just don't actually have to read. Look at this, so excited, already found his notebook. And I hope that's not the notebook you plan on using for this course, because you are going to need about 500 of them at that size.
Another one too.
This should go without saying, but do not study while you're lying in bed. You're not very likely to get anything done. So do not study while in your pajamas. It's mental. So if you're in pajamas, you're kind of like in relaxation mode, so you're less likely to absorb any information. So dress as if you're going into class or work. Again, preferably in a secluded area, like at a desk where you would normally do your homework. I've read studies where they recommend that you actually have music playing in the background while you study very softly. Especially your favorite songs. You say that if you're in a test, you remember lyrics of your favorite song, you can remember what you're studying when those lyrics are played. I don't know. I'm not going to lie, I was tell a student I never studied. But I do always have stuff on in the background when I'm working. So there's that. I say it makes me more productive, my wife say it doesn't. So take it for what it is. Do not wait until the last minute to do the assignments. Again, this goes without saying, yet inevitably, you will wait till the last minute to do an assignment. And this should also go without saying, but do not wait to seek help. Again, it inevitably happens. The day before the final, I get an email. How can I improve my grade? You could have come see me for help at the end of the semester when you're struggling. So if you're struggling, seek help immediately. Fellow classmates, the tutoring center, me. Let's have a great semester. At least this is not an 8 a.m. Calc 2. We're supposed to have one this semester, but I got canceled. And most importantly, this is the number one rule. Have fun. Any questions?
What is CAS?
It means computer algebra system.
Oh, okay, so like something online.
So the TI Inspire CX2 CAS is a computer algebra system. So essentially what it means is it can do symbolic manipulation. So it can solve algebraic equations for you. It can find a derivative function. It can find an antiderivative.
Okay.
A non-CAS, it's like just a regular graphing calculator, would only be able to find an integral, numerical. It would only be able to find a derivative at a point, so it would only be able to evaluate. It wouldn't be able to solve algebraic equations, it wouldn't be able to any kind of symbolic manipulation, it wouldn't be able to simplify a function, expand a function, factor, anything like that. So that's what a CAS is. Plus, CAS, if you're on a computer, also allows you to code, if it has a coding language. Which the CX2 CAS actually does. It has Python. It's very basic, but you can code on the calculator as well in Python. Very useful. Not technically mandatory. You could get through the in-class exams with just a graphing calculator. May not be as fun. But depending on your major, I would recommend investing in it. Engineering, math, oh yeah. Physics, here. Anything else? Pretest. So this is obviously going to test prerequisite knowledge that you're going to need for this course. The pre-cap's you're going to need, the calculus 1 you're going to need. If you cannot get at least a 70 on this, you're going to see me. It's a good time to explain how typically run the courses. Oops, not the class, book class. So in each module, you're going to see videos. These would be your typical lectures. Introduce you to whatever terms, theorems, proofs. And then the actual class time is going to be just a bunch of example problems. Using what's in the video. Maybe a few certain things in the video. I may review a important theorem that I need, important definition. And if there's time left over at the end of each of those, I will come over and do some homework problems. Which is what we're going to do right now. We're going to look at some of these problems from pretest. So think of this as your review of pre-calc and calc 1. And I always aim for a perfect score, so if anyone gives me a wrong answer, they lose 10% of their final grade. Unless it's their fault. Then you're safe. Rule about coding. If you send me a code and it crashes my computer, you're going to fail automatically. And if you get me sick, you're going to fail automatically. My kids get me sick enough, I don't need you getting me sick as well. Let's take a look. Limit. Did you go over the formal definition of a limit in Calc 1? Yeah, I know we did.
Yeah.
They're fun. I love the formal definition of a limit. We just see it again, by the way, when we study sequences. The formal definition, the epsilon thing for a sequence is epsilon n definition. But then there's the epsilon delta definition. It's math speak. Math is its own language. I would say I'm bilingual. I speak English and math. It is its own language. I do use a lot of shorthand, which is part of the math language. So if at any time you don't recognize a symbol, feel free to ask me what it means. Well, we're not going to use the limit definition because, my God, that's a pain in the ass to use to evaluate the limit. This is infinity too, which is really nice. For evaluating a limit, what do we typically do first?
For just any limit or limit?
Yeah, just any limit.
I would think you usually test the left and right.
All right, so if I give you limit as x approaches 1 of 3x plus 5, what would you do?
If x approaches 1, I would say plug in 1.1
Yep.
and 2.9.
Oh. Well, that's for tables.
Okay. Or maybe just plug in.
Yeah. No, we just plugged in 1.
Okay.
Right, that's for polynomials. You can do that as long as the function is continuous at the point. You can just plug it in. Then you also have the composite function theorem, which lets you do it for composite functions. So once you get like square root and sine, all that, that's where then continuity comes in. So that's typically what we do first, is plug in the value. Oh dear. We don't have a value, we have infinity. Well, we can still think of it as a value. I say think. It's not real things out of infinity. We'll see that when we study series. You take an infinitely large number and square it. It's still infinitely large, isn't it? And then you multiply it by 11. It's still infinitely large. Minus an infinitely large number. We can still kind of think of that as infinitely large. Plus 10. Well, that 10 doesn't freaking matter. And then we get infinitely large plus 7. So this is kind of like infinity over infinity. Which is not 1! It's indeterminate. Remember that? Means we have to do algebra. Technically, there's several ways we can do it. We can use L'Hopital's rule. Some cover that in Calc 1, some don't. I do. But this one I don't even need to use L'Hopital's rule on.
Do we do like the?
I just look at this.
Some sort of rule, maybe?
If you're considering an infinitely large term, so a googolplex, which is 1 followed by a googol zeros, which is a 1 followed by 100 zeros. So a googolplex is 10 to the 10th 100. It's a massive number. And you square it, it's going to be 10 to the 2 times 10 to the 100. Well, this term doesn't even really freaking matter at that point, does it? And that 10 is maybe a bacteria. So the 11x squared is your dominating term there. So for very large x's, you can think of the numerator as just 11x squared. Same argument, you can think of the denominator as just 9x. Well, that's what? 11 nines times x. What happens to x as x grows infinitely large? It grows infinitely large. This limit is infinite. No, not those. I mean, still O. Yeah, it's a shortcut. Right, so sometimes you get these boxes up here. You put that, or if you know the shortcuts, you can just use the shortcuts. So double O gives you infinity. Yay! Relatively stark. let's review. What is the derivative definition? I'm talking about the rules. I'm talking about the actual definition of a derivative. Slope of what?
Like the derivative of an equation, I think is the same as the slope of the equation.
So technically no, because slope is a number. But derivative itself is slope of the tangent line.
Okay.
Right? That's the geometric interpretation. It's not the actual definition. I'm going to use h or delta x. Doesn't matter, you use interchangeably. That look familiar? Should. That's the limit definition of a derivative. It's the limit of the difference quotient as your incremental change approaches 0. Right? So typically you see h, some texts use delta x. It just means the same thing. That is a pain to work with. So then we did a bunch of rules. Right? We had the sum rule, the difference rule, product quotient, chain rule, power rule, exponential rule, logarithmic rule, the trig rules, the inverse trig. What was that derivative? Derivative of the natural exponential function. Do you remember what that is? Keep in mind, it's not too late for me to go back and change Kaplan grades. I have a year.
I think it's EU prime over U. I know it's a fraction.
I agree there's an EU in there.
Okay.
Right.
Prime times b. Okay.
The derivative of what? The derivative of the exponent times the original function for exponential. Or for the natural exponential. The general exponential is different. We also have constant multiple rule. So if we look that function. It's 6 times the function. It'll be 6 times the derivative of the function. What is u?
It's just 3. No, sorry, u prime is 3. U is 3x plus 4.
U is 3x plus 4, so its derivative is 3. (18e) to the 3x plus 4 is that derivative. Nice. So in taking derivatives of composite functions, work your way in. Four times a cosine function. It's the derivative of the cosine function.
Negative sine.
And then don't forget chain rule. Right? So it'll be negative u prime times sine of u. Now work our way back inside. 6 times a natural log function.
U would be 6 times 1 over x, which would be 6 over x.
So the derivative of log of u is what?
U prime is x.
And u prime of u. All right, we get 4 times negative derivative of what we're taking the cosine of.
U prime over u, which is u prime over 6 over x times negative sine.
Then times, well, I already have the negative, so I don't need to worry about negative. Sine of u, which is 6 log x. So negative 24 sine of 6 log x all over x. No. This, yes. All right? And that doesn't count as one of my attempts to the second one, which is also nice. So you can actually check each part individually. So 4. So what do we do to find f prime 4?
You're gonna plug 4 into the derivative.
What's 24 over 4?
6.
Negative 6 sine 6. What's the log of 4?
1.3.
No, that's an approximation. It's a trick question.
Wait, you said natural log, right?
It's just log of 4.
Oh, okay, don't try. Okay.
Unless it asks you to, never approximate.
Okay.
All right, we're on this derivative. So what's the derivative? How would you go about it?
Yeah, well, it takes the derivative of e to the 9x, then the derivative of e to the negative 9x.
So what's the derivative of 9x?
The derivative of 9x is e to the 9. Is it just e to the 9x?
That.
Yeah. And then just e to the negative 9x.
Are you happy with that? No? Why?
Is it going to be like 9 multiplied by e in power
What'd you forget?
9 then?
Oh, okay.
You forgot the chain rule.
Okay, so it's 9 e negative 9x.
And then what should this one be?
Also 9. I mean, I guess it's going to be positive 9 now.
That minus can become plus, right? Because we're multiplied by a negative 9. We happy?
Yep.
It also would have accepted if you were factored out the 9. Ah, nice.
Piecewise function.
Right, so this introduces the ideas of left-handed, right-handed limits. Can zoom in. So, what's this first one? What are we looking for?
You're gonna plug 3 into the equation on the top.
Why?
Because there's a minus sign there, so it's saying as x approaches 3 from the lower and the symbol up there is less than or equal to, so it corresponds to.
So this first one is the left-handed limit, which means all the values of x are less than 3. So what should we get?
I got -8.
4 minus 3 is 1, minus 9 is -8. What about the second one?
I got 3.
So that one would be a right-handed limit, right?
Yeah.
So all of your values of x are going to be larger than 3.
Right. -8.
So what is the limit as x approaches 3?
-8. Because that one said or equal to.
Sure about that?
I mean, that's what I think, because it said less than or equal to, the limit is equal to, so that seems like it would include the top one. I think.
But when we take a limit, do we ever actually hit the point?
So do we have to take the left and the right limit for this one?
Which we already did, right?
Right. Oh, maybe. Maybe it doesn't, does it not exist? Because they're not going to the same number.
A limit exists if and only if it exists no matter how you approach the point. So for Calc 1 and Calc 2, that means the left-handed and right-handed limits are the same. When you get to Calc 3, you're going to see it's not as simple as that. Which, by the way, if we look at this, would this function be continuous?
No.
Nope. The limit does not exist, so it's not continuous. So let's write it out, because we have a new one. It's the derivative of tangent of u. Okay, started. U prime, secant squared.
Yeah.
So what's the derivative function?
Okay, so we're going to be sin x minus 5 secant squared x.
Happy with that?
I believe so.
You believe you're happy?
Yes, I'm happy with
Uh-oh.
that. I
You
believe
don't-
that's the answer.
You don't even know if you're happy. That's not good. Yes. So terminology. We call this the derivative, right? That's not actually a derivative. The derivative has a specific meaning. And if you look at the interpretation of derivative, it's a slope of the tangent line. Slope is a number. So the derivative is always a constant. What we found is actually the derivative function. But that's a mouthful to say all the time, so we just shorthand it. Derivative. It's the same thing when you look at integration. An integral is always a number. What they call improper integral is actually an antiderivative. So again, we'll typically just say integral to mean both of them. That's not technically correct. So you'll hear me say antiderivative a lot, and I just mean improper integral. Whenever I say integral, I mean the area under the curve. And the proper integral. Again, even that is misleading. Because the integral that we study is the Riemann integral. There are other types of integrals. One I studied in grad school was called the Lebesgue integral, which is calculated completely differently. It doesn't use Riemann sums, it uses measure theory and measures. Don't ask me what they are because I don't remember. It was confusing, I just know that. But a lot of functions that don't have a Riemann integral actually do have a Lebesgue integral. That's why I love math. So we want the derivative at 4. What do we get?
Do we just put negative sine 4 minus 5 secant squared of 4?
What is sine of 4? Sine of 4. Right?
Yeah.
Secant of 4 is just secant of 4. Now, another thing about math is it's 90% aesthetics. That is not how I would write it. Because I think negatives are ugly.
Oh, so you factored
I hate negatives, so I will always write it in the way that gives me the least amount of negative signs. That is just my preference. That is not a requirement. And of course, it is set up that it will accept equivalent forms. So I'm also fairly confident if you replaced secant squared with tangent squared plus 1, and wrote that as 5 tangent squared of 4 minus sine of 4, negative 5 tangent squared of 4 minus sine of 4 minus 5, it would also accept that. Right, so it should also be set up to recognize all trig identities. Also, while I'm on the topic of trig, what mode should your calculator be in?
Oh, radian mode.
Radians, unless the problem specifies otherwise.
Yeah.
Angles are always measured in radians, unless specified otherwise. Check your calculator mode. There's nothing worse than getting a question wrong because you're in degree, not radian. I see that a lot. Most of the time it's different between A and B. The hell? You don't do one like this. You're boring. I don't have the answer. you all agree? Equation of a tangent line. So if we're looking at the equation of a tangent line at the point x naught, y equals this will be the form. Or slope times x plus your intercept b. And that's just by collecting like terms. So to find slope, we need f prime. So let's write this down. What's f prime?
Negative 15 given the x plus 1. Or write that one also.
Yeah, remember, it's statics. So you're correct. What is the slope then?
Probably negative 15. Yeah, are we, I guess, is that, already mx plus b? Or we have to go?
No, no.
Oh, okay.
This is just f prime. Remember, what is slope?
Yeah, okay, you gotta go over there, okay.
How would you find slope?
I think we're probably plugging into that equation there, right? Like it's, so I guess.
Well, you don't have to. We use this equation.
Okay.
But slope would be just this term here, right?
Oh, okay.
What's x naught?
Three, isn't it? No.
0.
Okay.
So you do what? Plug 0 into here, right? Which is what?
Yeah, so. Oh, I guess it's negative 11.
Negative 11.
Yeah.
Then what would the intercept be? Well, it's f of x naught, which is what?
Negative 11. Right? No, F of. Oh, yeah, yes.
Right, so f prime of x naught is
Negative
negative 11.
Okay.
What is f of x naught? So what is f of 0? Like can already see you're doing too much.
Okay, so 12.
You're already doing too much.
Okay. Oh, negative 3. Okay.
All right, they already gave you the point in order to pair.
Yeah.
So f of x naught is equal to 0, which is just f negative 3.
Yeah.
Right? Minus f prime of 0, which is negative 11,
Okay.
times 0.
This is 0.
So b is negative 3.
Yeah.
Okay. It's also important you read instructions. They specifically tell me here no fractional or negative exponents. How do we do this?
The first thing I want to do is try and rewrite that.
So I'm going to write the original function first. And you said you would rewrite that. How would you rewrite it?
10 to the 10x to the 1 half plus 2x to the negative 3.
Okay? What's that derivative?
That's as far as I got. 1 second. So yeah, 5x to the negative 1 half minus 6x to the negative 4.
Happy with that?
No, because it said no negative x.
So, not correct because of the instructions.
Right, so we have to rewrite that.
So how would you rewrite this to match what they want?
Let's see. 5. We're going to put 5 radical x. Oh, wait. You can't do that either.
So let me ask you this. How'd you get this x to the minus 3?
Square root. How do you get x to the minus 3?
How'd you get that x to the minus 3?
Under the fraction. Look at that.
So there's a radical x, but where is it?
In a fraction.
Where in the fraction?
The denominator. 5.
Right, this would be 5 over x to the half, which is 5 over root x.
Right.
And then what's this?
That's not negative 6 minus 6 times 1 over x to the 4. Which is just 6 over x to the 4. Yeah.
Now, they didn't say to write this as a single fraction. So it should accept that. I don't like multiple fractions. So I'm going to make you go further. I want that as a single fraction. How would you do it?
Let's see. Yes, for one thing, I'll multiply that 5 times radical x over radical x. So we get 5.
I wouldn't. You're trying to rationalize what you don't have to do.
Okay.
So I personally wouldn't do it